Hello. Okay, so we are going to start our new unit on polynomials, and what I would just want to go over is what a polynomial is, and then start talking about something called end behavior and just how those things work. So this will be our first part on polynomials. So remember, a polynomial function is in this form. Now that it looks really complicated. Really, there's just a bunch of variables in there. Really, a polynomial, right? This is just saying it looks kind of like something like this, right? Where a sub n minus 1, a sub n minus 2, all those things are just numbers. They said they're real numbers, but they're like 12 down here at the bottom, or negative 11, or 31, or whatever. And also that these exponents right here are positive integers. So 2, 3, 4, etc. Integers. So in other words, no negative exponents, only positive integers. So that's a complicated way of saying what we just talked about. But you'll see this written in like calculus books instead to generally define them. A sub n, the number that's in the front, if you remember when we talked about polynomials in Algebra 2, this is called a leading coefficient. Okay, and remember, those are all these numbers, right, are coefficients. These are whatever numbers there are in front of that, in this case, x. Those are called coefficients, and the one, once you put it into standard form, which should be the highest power, or highest exponent, we call that the degree, and whatever numbers in front of that would be the leading coefficient. So, if you don't remember that, that's okay. Let's just look at some of these things here. So, this is a function like, remember f of x is the same as y. So this is really like saying y equals 4, okay? And in order to determine the degree, we say, what is the biggest exponent on the variable? So you would say, well, what is the variable here? There is no x, right? Or another way to say that is it's x to the 0 power, which is just 1. So I like to think of it, there's no x, so the degree is 0. What's the leading coefficient? Well, there's only one thing there, it's 4. So that might be a little confusing, so it might be easier to look at some of these other ones. So, all right, you've got degree. You're going to look here. What's the exponent on the biggest one? So in this case, we only have one x, and the degree on that, or the power on that, is 1. So that means that polynomial has a degree of 1. Okay, and the leading coefficient is negative 5, the number in front of that biggest exponent. Okay, so, all right, whoops. So by that token, then we would say this one would have a degree of 2, because this is our biggest one. And then the leading coefficient would be the number in front of that coefficient there, 12. Okay, so hopefully you remember some of this. This would be 1, or 3 and negative 1. Our degree is 3. The leading coefficient, there's nothing written there, so it's negative 1 because it's negative. So this one would be degree of 4, leading coefficient negative 3, degree of 5, leading coefficient 9. Okay, you might say, well, why do I need to know that? What difference does that make? The degree of a polynomial tells us how it behaves, what it looks like, tells us what the graph looks like, and so that's really important. And then the leading coefficient also impacts what it looks like as well. So those two pieces of information, just knowing those two things really help out a lot. All right, so let's talk about some parent functions. Remember, parent functions are things that really, if you modify the parent function, you get all kinds of different versions of the parent. Okay, so those would be like the babies of the parent function. But you just modify that main one called the parent function. So a constant function would be like y equals a constant, we call that c. So like y equals 5, for example, would be a constant, and that would look like that. It would be a horizontal line. So all constant functions look some variation of that, okay? Linear functions would be like y equals x, okay? Y equals x This is a linear function. It's going to be a line. You know all about these. But y equals x looks like that. Right down through the origin and a diagonal line. Now, you know y equals mx plus b. Those are just transformations of this linear function, the most basic one, y equals x. And so by all that token, these are all things that quadratic functions like y equals x squared. Okay, so that's the most basic quadratic function. And you know that that's a parabola. Oh, I didn't draw that very well. That looks kind of like that. And then all quadratic functions are some version of that. Okay, cubic functions, as you might guess, is x to y equals x to the third. And they have this kind of looks like a yeah, I don't know, just like a squiggly line. It's got that squiggle in the middle and it should go through, pass through the origin there. I didn't quite reach that, but you get the picture. And then let's talk about quartic and quintic ones. This would be, quartic is to the fourth degree, okay? So this would be y equals x to the fourth. Now, surprisingly enough, this one looks like a quadratic function. It should touch the origin there, but so really it looks like that, but that's not super useful. So I actually want to give you another picture here. And I think you should put this in here as well. Quartic, usually when you graph and modify this slightly, it's not going to look like a quadratic, so that's how you can tell it's quartic. It looks sort of like a modified W a lot of times. So you're going to see something that maybe might look like this, where you'll notice two low ones, two kind of bumps there, and at the bottom, troughs. Sometimes it's flipped upside down, so that could vary as well, but just kind of keep that in mind. And then quintic ones also, this is not super helpful because it kind of looks like this, and that looks like a cubic function. Well, let me give you another example of what this might look like. Let me zoom in here a little bit. So perhaps a bit better might be something that looks like this. Okay, and we'll talk about how you notice a couple of bumps on the top there, a couple of bumps on the bottom. And so you can kind of tell the difference of what's happening there. But the way that I kind of look at that, well, we'll talk about how you can tell the difference here in a second. So that might be easier to describe here in a sec. All right, so this would be y equals x to the fifth. Okay, so now let's talk about some end behavior. Okay, so this is using your graphing calculator, determine the end behavior of the following functions. What I did on this sheet is I put in all the graphs of these functions and what they look like. So this first one on the left, number 1, is this graph right here. So maybe you need to put number 1 there. I try to put them next to each other, but it says as x, it says f of x is equal to, remember that's just y, equal to 4x to the fourth plus 6x to the third minus x. And then it says, as x approaches infinity, that's what that means. As x gets closer to infinity or goes towards infinity, what happens with f of x? Remember, f of x is y. So as x goes towards infinity, what happens with y? And then by the same token, as x goes to negative infinity, what happens with y? Okay, or f of x. So let's look at this right here. So as x, so think about starting at the origin. As x goes towards infinity this way, what's happening as that gets bigger, as the x value gets bigger, what happens with the y value? Remember, the y value is this. It controls up and down. So you'll notice that this graph is actually, as x goes to the right, this is going up, okay? So that means it's approaching, y is approaching positive infinity. It's going way up, and it keeps going. So it goes towards infinity, okay? Now, what about, this is kind of weird the first time you do it, so it's okay if you're still a little confused. As x goes towards negative infinity, okay, so what does that mean? So start from the origin. As x goes this way, towards negative infinity that way, what happens with y? Well, you'll notice it's going up, okay? It's getting bigger, and it's going up towards positive infinity as well. So this also goes towards positive infinity, okay? All right. A little weird. Let's take a look at our next one here. All right. As x goes towards infinity, f of x does what? So this one, notice it's a x squared, and it's a quadratic function. It turns upside down. So as x goes towards infinity, so as x goes this way, what's happening with y? You'll notice it's going down right there, right? So it's approaching negative infinity, okay? It keeps going all the way down, and that's how we get that. All right, what about as x approaches negative infinity? Okay, you notice go that way. What's happening with y? Well, it's also going down. So this is also approaching negative infinity. Okay. I hope that makes some sense. Let's keep going so you get a little used to this. All right, so as x approaches infinity, going this way, what's happening with f of x? It's going up. So this would be towards positive infinity. All right, cool. How about this one? As x approaches negative infinity, what's happening? This is also going towards negative infinity, right? Okay, cool. We did that and behavior. All right, so now let's look at this one. This is notice it's a cubic function, and it's squiggly. It's got that little curve in the middle, and that's sometimes more pronounced than other times. But this time it's flipped around, and that's because of that negative in the front. Okay, so as x approaches this, what happens with y? It's going down towards negative infinity. So this would be negative, f of x approaches negative infinity. And then as we go this way, what happens? It's going up. So f of x, or y, is going towards positive infinity. All right. That's how this works. So now this one, I'm not going to write it out. As x approaches infinity, what happens with f of x? You'll notice it's going towards negative infinity. Okay. As x goes towards negative infinity, what happens with y? It's also going towards negative infinity. Okay. This one, cubic function again. Notice a little squiggle there. As x approaches infinity, this one also, f of x also approaches infinity. As x approaches negative infinity, f of x also approaches negative infinity. Okay, cool. So now let's make some generalizations about what's happening. And honestly, all this work that we just did, if you make a generalization using this chart that we're about to, this chart is going to be super helpful for you. Let's generalize what we just learned, okay? Positive leading coefficient, okay, and an even degree. So let's find one that has a positive leading coefficient and an even degree. That would be number 1. Okay, positive leading coefficient, even degree. Degree is 4. Okay, so what do we notice? Well, this sketch will actually kind of help you. On the left, it's going up. Okay, as x approaches negative infinity, it's going up. As x approaches positive infinity, so does f of x. So it kind of looks like that. Notice this is going up, up. Okay, and that's going to be helpful as you're starting to think about what's happening. Okay, odd degree, but a positive leading coefficient. So we're going to fill in this box right here. Odd degree, but let's see, a positive leading coefficient. So that would be this one. Okay, So what's happening here? As x approaches infinity, f of x goes up. As x approaches negative infinity, this goes down. Okay. All right. Negative leading coefficient and an even degree. Here's another one that was the previous one that we just did, right? Positive and odd. Okay, notice it has same features. Okay. All right, negative leading coefficient and even degree, so that would be like number 5 there. Okay. So this one, notice that graph, they're both, it's going down on both ends there. Okay. And then number 6, nope, negative and odd. So I guess that's number 4, sorry. So that would be, notice the pattern there, one's going down this way and this one is going up. So that's great. This chart now is super useful. You'll probably come back to this quite a few times because now I can answer questions like this. I can just look at it and I can say, all right, it says determine the sign of the leading coefficient and whether the function has an even or odd degree. Well, notice down, down. So which one is that? It's this right here, right? So this is going to be a negative leading coefficient and it has an even degree. Now, this actually would be a 4th degree, a quartic, right? Because I can see those 2 humps. It's just turned upside down, so it kind of looks like this one right here, but it's been flipped around. But knowing that it has an even degree, I know that it's going to be quartic, okay? A 4th degree, so that helps. Okay, this one. Now this is actually a cubic function. It's got the squiggle, but notice it's way more pronounced in the middle. But you might not know that until you looked at some of these other things. So now it says it's going, let's see, it goes down here. And then as x approaches infinity, y does too. So that would be an odd degree. And it's a positive, using that chart, leading coefficient. So this is actually, like I said, a cubic function. Okay, lots of information, but we're going to stop there. Hope that makes sense. All right, see you, everybody.